For decades, the idea of humans traveling beyond Earth orbit felt like something locked in the past, a relic of the Apollo era that the world had quietly moved on from. The last time anyone went that far was in 1972, and since then, space exploration had become routine, almost predictable. Rockets launching, satellites deploying, astronauts circling Earth, but never truly leaving it. That's why when Artemis 2 lifted off, it didn't just mark another mission, it marked the end of a 50-year silence. 4 astronauts stepped into a moment that hadn't existed for an entire generation, climbing aboard a spacecraft designed to go farther than any human had gone in decades. Reid Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen weren't just a crew, they represented a shift. For the first time, a woman, a non-American, and a person of color were all part of a mission leaving Earth orbit, something that had never happened during the Apollo era. And as their spacecraft pulled away from Earth, shrinking the planet into the distance, it became clear this wasn't just about revisiting the moon, it was about redefining who gets to explore it. But as historic as that moment was, NASA wasn't simply trying to recreate history. They were testing something new, something riskier, and what came next would push this mission far beyond a symbolic return.
Instead of retracing the exact steps of the Apollo missions, Artemis 2 followed a path that was both deliberate and far more unforgiving. A free return trajectory that would carry the crew around the moon and rely entirely on its gravity to bring them back home. On paper, it sounds simple. In reality, it meant once the spacecraft committed to that path, there was no easy way to adjust, no second chances, and no turning back without major risk. Every calculation had to be perfect. As the spacecraft moved farther from Earth, the distance quickly became more than just a number. It became something the crew could feel. The planet they had just left behind began shrinking rapidly, transforming from a massive, detailed world into a small, glowing sphere suspended in endless black. And then came the moment that quietly rewrote the record books. Artemis 2 passed the farthest distance ever traveled by humans, surpassing the mark set by Apollo 13 over 50 years ago, pushing beyond 252,000 miles from Earth. At that point, they were farther from home than anyone in history had ever been, entering a region of space that had remained untouched by human presence for generations. But this wasn't just about distance, it was about scale. For the first time ever, 4 astronauts were traveling together in deep space, something even the Apollo missions never attempted. More people, more systems, more complexity, and more that could go wrong. Every mile added pressure, not just on the spacecraft, but on the mission itself. And yet, instead of celebrating the record, the crew made something unexpectedly clear. They didn't want to hold it for long. In fact, they hoped it would be broken as soon as possible. Because if this moment stood untouched for another 50 years, it would mean something had gone wrong, that progress had stalled once again. That mindset shifted the meaning of the mission entirely. This wasn't about beating the past. It was about proving that humanity was finally ready to move beyond it. But as historic as that distance was, it still wasn't the most unforgettable part of the journey. Because as they approached the moon, what they saw would change how we look at it forever.
As Artemis 2 swept around the far side of the moon, the mission shifted from record-breaking to something far more unexpected: discovery in its purest human form. For the first time in over half a century, people weren't just studying the moon through cameras or data feeds. They were seeing it with their own eyes again. And almost immediately, something felt different. The surface didn't look the way most people imagine it: flat, gray, lifeless. Instead, the astronauts described subtle variations that don't fully show up in images. Faint hints of color, with patches appearing slightly green or even brown depending on the angle of sunlight. Craters and ridges cast deep, dramatic shadows that made the terrain feel sharper, almost surreal, like a landscape that shouldn't exist. One of the most striking features was the massive Orion Basin, a crater stretching nearly 600 miles across, revealed in a way it had never been seen before, fully illuminated and incredibly detailed. It wasn't just a scientific observation, it was overwhelming. Even seasoned astronauts found themselves caught off guard by how alive the moon seemed up close. And as they continued their flyby, scanning features that had only ever been studied from a distance, it became clear that human eyes were still uncovering things machines had missed. But just as they were taking it all in, something happened that no one had planned, and it would become one of the most unforgettable moments of the entire mission. Right in the middle of Artemis 2's lunar flyby, the mission took an unexpected turn, not in trajectory or systems failure, but in pure cosmic timing. As the spacecraft rounded the moon, the geometry of space lined up in a way that very few missions ever get to witness: a total solar eclipse from deep space.
But this wasn't anything like the eclipses we experience on Earth, where totality lasts only a few minutes before the sun slowly reappears. From the astronauts' perspective, the moon wasn't just covering part of the sun, it was completely swallowing it, stretching across their entire field of view and blocking sunlight for an incredible 54 minutes. For almost an hour, the cabin was filled with an eerie, shifting darkness, broken only by the faint, glowing outline of the sun's corona, wrapping around the moon like a burning ring suspended in space. It was the kind of sight that doesn't just feel scientific, it feels unreal, almost impossible to fully process in the moment. The crew described it as overwhelming, something that even their training couldn't fully prepare them for, because no simulation can truly recreate what it means to watch an entire star disappear behind another world while floating hundreds of thousands of miles from Earth. During that extended eclipse, time itself seemed to slow down for the astronauts. There were no procedures demanding immediate attention, no critical burns or system checks, just a rare window where the mission paused in the most literal sense, giving them a chance to simply observe something no human had ever seen in quite this way before. But even in that moment of awe, the awareness of where they were never fully disappeared. Because as beautiful as the eclipse was, it was also a reminder of how isolated they had become. Cut off from Earth, surrounded by deep space, with only a thin spacecraft shell separating them from the void. And eventually, as the moon continued its silent path and the sun began to re-emerge, the reality of the mission returned with it. The calm wouldn't last long, because ahead of them lay the most dangerous part of the entire journey, reentry. A phase where everything that had gone right so far would be tested in seconds, not days, and where even the smallest uncertainty could turn into a life-or-death situation. As Artemis II began its long journey back toward Earth, the tone of the mission quietly shifted again. From exploration and awe, back to tension and precision. Because no matter how smooth everything had gone so far, everyone on board knew the hardest part was still ahead: re-entry. Coming home from the moon isn't like returning from low Earth orbit. It's a completely different level of speed, heat, and risk. The spacecraft would slam into Earth's atmosphere at around 24,000 miles per hour, fast enough to turn the air around it into a superheated plasma, with temperatures reaching up to 5,000 degrees Fahrenheit. At those extremes, even the smallest weakness in the spacecraft's protection system becomes critical. And that's where concern quietly lingered in the background. During the previous uncrewed Artemis I mission, engineers discovered unexpected wear on Orion's heat shield, small cracks and erosion patterns that raised serious questions about how it would perform under real human return conditions. NASA chose not to redesign the shield for Artemis II, instead adjusting the re-entry angle to reduce the duration of peak heating, a decision that balanced engineering confidence with calculated risk. But no matter how much planning went into it, there was still one moment that no simulation could fully remove the tension from: the long communication blackout during re-entry. As Orion hit the upper atmosphere, it would become surrounded by ionized plasma, cutting off all radio contact with mission control for several minutes. In that silence, there would be no updates, no confirmation, no reassurance, just uncertainty. And for those few minutes, as the spacecraft plunged deeper into the atmosphere, even the most experienced engineers admitted there was always a quiet, unavoidable question hanging in the air. Would everything hold together or not? Long before Artemis II ever touched Earth again, there was a quieter side of the mission unfolding, one that had nothing to do with records, trajectories, or engineering milestones, and everything to do with the people inside the spacecraft. As the crew passed around the far side of the moon and continued their journey, moments of routine check-ins and observations were interrupted by something far more personal. During one of these deep space passes, a request came through from the crew that wasn't part of any official flight plan. They wanted to name two previously unmarked lunar craters. One would be linked to their spacecraft, Integrity, and the other would carry a deeply personal meaning for Reid Wiseman, honoring his late wife, Carol, who had passed away years earlier. In that moment, hundreds of thousands of miles from Earth, the mission stopped feeling like a technical demonstration and became something else entirely. The astronauts weren't just reporting data anymore, they were processing emotion in real time, in one of the most isolated environments humans have ever experienced. Even through radio transmissions, Mission Control could hear the shift in tone as the crew tried to hold back emotion while making the request, and it didn't fully work. What followed wasn't just approval of a symbolic gesture, it was a rare acknowledgement that even in space exploration defined by precision and control, human connection still finds a way to break through.
And in a mission filled with firsts, this moment stood out not because of what it achieved technically, but because of what it revealed about the people experiencing it, and how quickly deep space can turn even the strongest training into something deeply, unmistakably human.
At first glance, Artemis 2 looked like a historic test flight, an ambitious but controlled mission meant to prove that NASA's new rockets and spacecraft could safely carry humans beyond Earth orbit again. But underneath the records, the flyby, and the emotional moments, there was a much bigger objective driving everything forward. Artemis 2 was never just about returning to the moon, it was about staying there. NASA's long-term vision is to build a sustained human presence near the lunar South Pole, a region believed to contain water ice trapped in permanently shadowed craters. That ice isn't just a scientific curiosity. It could be broken down into oxygen for breathing, water for survival, and even hydrogen and oxygen for rocket fuel. In other words, the moon stops being a destination and starts becoming a fuel station, a stepping stone that could completely change how humanity operates in space. But that's only part of the picture, because while NASA is building toward this future step by step, they are not doing it alone, and they are not the only ones racing to get there. China has also announced plans for crewed lunar missions before 2030, turning what looks like exploration on the surface into a quiet but very real competition beneath it. And that changes everything about Artemis. It's no longer just about science or exploration, it's about timing, momentum, and who defines the next era of space travel. Artemis 2 wasn't designed to land on the moon, but to prove that the path back is stable, repeatable, and ready to scale into something much larger. Because once that foundation is set, the next missions won't just orbit or fly by, they'll begin building, landing, and staying. And that leads directly into what comes next. A future where Artemis stops being a mission name and starts becoming a permanent presence beyond Earth.
When Artemis 2 finally splashed down in the Pacific, it looks like the end of a mission that had already achieved everything it set out to do. Records broken, milestones reached, and the moon visited for the first time in over half a century. But in reality, it wasn't an ending at all. It was a checkpoint in something much larger that is still unfolding right now. Because Artemis 2 wasn't designed to prove that humans can go back to the moon. It was designed to prove that we can keep going. That deep space isn't a one-time achievement from the past, but a direction we're actively returning to. Every part of the mission, from the free return trajectory to the extended lunar views to the risky but successful reentry, was a test of whether this new generation of spacecraft and astronauts could handle the kind of journeys that future exploration will demand. And now that those systems have been pushed, tested, and brought safely home, the path forward is suddenly open in a way it hasn't been for decades. Artemis 3, Artemis 4, and beyond are no longer abstract plans. They are next steps already in motion, leading toward a permanent human presence near the moon, and eventually something even bigger. But the most important question isn't what NASA will do next, it's what humanity will do with this moment. Because if Artemis 2 proved anything, it's that returning to deep space is no longer the hard part. The real challenge now is deciding how far we're willing to stay.